In lots of real world settings like reviews, customer support tickets, and social media posts, we want to automatically tell whether text is positive or negative. The usual recipe is to take a big pre-trained language model and fine-tune it on labeled examples. That works well when you have plenty of labels. But labeled data is often the bottleneck. You might only have a few hundred examples, or labeling is slow and expensive. In those low resource situations, the open question is, should you still update the whole model, or can you get away with something lighter? We use SST2 from the GLUE benchmark, which is a binary sentiment classification task on single movie review sentences. Each example is one short piece of text, and the job is to decide if it's negative or positive. The input to the model is one sentence as raw text, and the output is a single class labeled 0 for negative or 1 for positive. Now, to simulate the low resource settings that was talked about earlier, we only change how many labeled training sentences are used: 100, 500, 1,000, or the full training set. We use two standard pre-trained encoders, RoBERTa base and DistilBERT base. The protocol is the same for both: same splits, same subset construction, same validation set, and same metrics. The goal is to compare three adaptation strategies on each backbone. These include full fine-tuning, a frozen encoder with only the classification head trained, and prompt-based classification with the masked language model, without supervised fine-tuning on the task labels. By training each model and each method on the same nested training subsets, this setup lets us ask which encoder and which strategy works best when data is limited.
SST2's official score is accuracy on the dev set, and therefore our results are based around accuracy. First, a line chart of how each method behaves as we add training examples. A few patterns can be seen. Full fine-tuning climbs sharply as we add data for both encoders, and RoBERTa fine-tuning ends up strongest at 1,000 samples. Frozen RoBERTa improves as we add data too, but the frozen DistilBERT runs don't show that same upward trend at 500 and 1,000. Now for our bar chart, at 100 examples, DistilBERT fine-tuning outperforms RoBERTa fine-tuning, but by 500 and 1,000, RoBERTa fine-tuning pulls ahead. To wrap up the analysis, supervised fine-tuning is the setup that scales most clearly with more labeled data here, and RoBERTa leads on average at the larger subsets. Our frozen DistilBERT at 500 and 1,000 doesn't improve the way RoBERTa frozen does, and we shouldn't gloss over that. A couple reasons can explain that gap. Dodge and colleagues fine-tuned BERT on glue hundreds of times with identical height parameters and only changed the seed. They report large outcome variance, and on small training sets, many runs diverge during training, so bad performance isn't explained by dataset size alone. Second, our own setup. We may not have found head-only settings that work at 500 and 1,000 labels, and optimization may not have gone well. Delvin and colleagues describe BERT fine-tuning where learning rate is chosen using the development set, so the model does well on that split. Our DistilBERT code uses a fixed learning rate with no dev set sweep, which could have led to performance issues. In conclusion, the best choice depends on how much labeled data is available. When data is very limited, around 100 examples, DistilBERT with prompt-based classification is the cheapest and most practical option and can be competitive in accuracy without any task-specific training. As the dataset grows to 500 or 1,000, supervised methods become the better choice. Full fine-tuning scales consistently with more data, with RoBERTa fine-tuning achieving the strongest performance overall. Frozen encoder training is less reliable, RoBERTa improves with more data, but DistilBERT does not show the same gains. At larger dataset sizes, the decision becomes a trade-off between computational cost and accuracy. Full fine-tuning gives the best results, but lighter methods may still be preferred if training cost or time is a concern.